My name is Kathy Jory. I've been with Mozilla for about a year, and I'm in a group called Emerging Technologies, which is kind of an R&D branch of Mozilla, where we're looking for future technologies and how to protect, put people first. The foundation sets the agenda for the corporation, and we want to do things that always protect people's privacy and security, promote interoperability through the W3C. And that's what this project is all about. We're looking at the Internet of Things and how do we protect people with this type of technology. And so the main difference between what you find commercially available and what we're doing is that when you buy stuff today, and I do this all the time, I pull out my smartphone, go to the App Store, download an app, do some fancy magic dance and QR codes or Wi-Fi connect or whatever it is to talk to the device, tell the device to get onto my network, and usually, pretty much it only gets onto my network so that it can talk to the cloud. So automatically your device and the data and what it's doing goes to the cloud, and then you end up with apps galore. Instead, the Mozilla approach says, why don't we just bring these things, these Internet of Things devices, bring the data of them one layer higher to the web, but the web doesn't mean cloud. The web just means, running at a web layer so that you can address them as URLs on your local network. Now, not all of these devices speak web, so that's where in the gateway project that we're doing is we have adapters, and my little Raspberry Pi right here has this little USB dongle. That's a Zigbee dongle, so I can talk to these Samsung SmartThings devices. So that's, in a nutshell, what's different is we want to promote that your data stays in your home. You can talk to it in your home. You can keep it in your home, and you would set up secure web tokens if you want to exchange data with third-party products and services. If your smart appliance needs more detergent, you could allow it to tell whatever, or if you have a maintenance situation, you could allow your smart appliance to tell the manufacturer some data that helps them figure out what you should do, something like that. So I also, before I go into too many more slides, I kind of wanted to do a live movie trailer type of demo so that you can play with or see what we're doing before I get too far. So I'm going to do a little preview of, whoops, I'm on the wrong page. There we go. So first, I'm going to go to a live Raspberry Pi that's sitting on my desk in Mountain View, and the release that's coming out overnight will have OnVIF camera support. And so OnVIF camera streaming data, you don't have to send your data to the cloud, but you can fetch it through the internet. One thing I forgot to mention with the Raspberry Pi paradigm, one thing we're doing right now, this year we'd like to move to commercial routers so that we're at the edge of the network so that you can access your data directly, securely over the internet. But right now we have to run this tunneling service to get inside your firewall. So when I stream back to my office Raspberry Pi, I'm just tunneling over HTTPS into my home office to see those pictures and videos. And then I'll show you this local gateway and show how to connect new things, show you how to use voice. I have this little USB speaker microphone, and I'm going to do local voice, not sending my audio to the cloud. And then we're going to do a gateway setup from scratch. And Tom, my college friend, colleague here, was nice enough to buy me one of these Pi hats. Is anyone in the room part of the team that did this Pi hat? OK. We have, there's two add-ons that I can show you when we get to that part about like addressing GPIOs on the Pi, or there's a generic sensors add-on that a guy from Samsung made, and you might look to see if we could talk to these things. That's your challenge, because we'll set this one up. And then last, I'll show you how to build some web things using microblocks. Again, I was in part of the Home Assistant tutorial here yesterday afternoon. And although cool, I was like, you know, it's back to that. I have to painfully follow instructions. And hopefully you'll get the sense that programming can be fun for everyone without being too difficult. And microblocks, for me at least, makes it really easy because you can copy and the functional blocks are at a high level. So we'll build some web things and then you'll all get to talk to the new gateway we set up. So let's go on to those live demos. Let's see, things gateway. Okay, so this is the, let's not start there. This is the Raspberry Pi sitting on my desk. So I should probably mirror this. Well, let's see. The what? Oh, yeah. I'm just trying to figure out where's my mouse? There we go. All right, so this is the camera in my office in Mountain View. And there must still be someone there because there's light. We have these motion sensors. And so if someone's around, the lights will be on. But you can see I have a pile of stuff.
7 at night, so somebody's probably there.
Somebody's still there. You know, those mixed reality guys are always there. All right, so there's my, but you can see these lights are not on. So what I'm going to do is just say, oops, let's turn on some things. So I have 2 other Raspberry Pi sitting on my desk, one with all the commercial stuff. So this is a whole bunch of commercial stuff or virtual stuff, Samsung smart buttons and motion sensors and other Philips Hue bulbs and IKEA bulbs and smart plugs and a whole bunch of random stuff. And then I have a virtual switch I made called My House so that I can turn everything on at once. So this is an example of using the internet to use your voice because obviously it's hard to get my voice in Mountain View, so let's try that. Turn on My House. Okay, so there's my stuff. Yay. Now let's go see, oh wait, let's turn on more things. So I have another Pi there with all my maker stuff. And this just shows the floor plan view. And remember, I'm fetching all this data from Mountain View for these ones. Okay, so for this one, I think I have, what is it, the snow pixel? Yeah, the snow pixel turns them all on. Let's go back here and take a snapshot. And now things are on. And you can see that the snow pixel was this guy, and these guys here, they're all white. Let's go change their color. I have some rules like, oops, that's not what I wanted. Let's go back over here. It's easier. So I have a rule where I can change the color of, that's not what I wanted. Change the color of this one, and based on setting the color, the others fall in line. Like, for example, red sets a rainbow pattern because I have a rule. Okay, now I have a rainbow. And so now if I go back here, I should probably turn off My House so I can see the rainbow better. All right, close that. That was a snapshot, which works better than the streaming right now. Okay, so now it's really, cameras wash it out, but this actually is a rainbow. If you were there physically, it would look pretty and colorful. And I turned off all those other lights. Now, if the demo gods are with us, we could actually see some streaming. And one of my little microbits is actually doing a heartbeat pulse. So that's how I can tell if something's live or Memorex, because, let me see if I can scroll a little bit. Yeah, there's my heartbeat right there. You can see little things flashing. So it's actually streaming. Not bad. It is. You can see, right. Okay, stop that stream. All right. I want to quick show you how you discover things. So we're going to go back over to here. is my Guardian one. This is actually has a fake kitchen. If I scroll up here, you see down in the lower right, it's a virtual things, and it has a fake switch, just so I can get things started. And you can see just basically how the GUI works. Now, we haven't had a user expert or user interface design expert do this stuff yet. It still is pretty simple to use. The little splat icon takes you into more complex stuff, like this is the colored light, how you can change the color and things. But to make a long story short, the plus button is how you discover new things. And so when I click plus, I have the virtual add-on adapter, so even if you have no virtual things or no real things, people can play really easily. So it loads up the virtual things. And then I unboxed 2 out of 3 of these guys already, the door sensor and the leak water sensor, because the leak water sensor is just part of our brand new release. So I actually hadn't used it yet. These were all brand new. I'm going to pull these out of the box. And we're going to, so this is a leak sensor, water leak sensor, and this is a door sensor. And we're going to say, yeah, let's just call this the door. And let's say that, and let's just call this leak. Done for now. And then what should happen is my door sensor, when the door is open, it should, hello, earth to door sensor. Okay, it also has these other indicators in here as well. Let's see, just make sure that's talking to me, hold on. Okay, come on, open. Oh, that's weird. Yeah, I mean, sometimes, believe it or not, you go into the console. Sometimes what's going on is basically the web sockets are lost. So it's not that it's not getting the data, but when these things go dim, sometimes there's a loss of web sockets. And I don't know why, but. All right, we'll come back to that one. This one, I actually need to get it wet to see if it. Yeah, somebody has an open water bottle. I just don't actually know what, there's little, does anyone use one of these? There's little contacts on the bottom and on the top, and I don't know if it's one or the other. It's the bottom ones? Well, why do they have these ones? This one's.
Because the water goes from the top outwards.
Okay. I don't know. This is the first, I just literally opened this for the first time, so we'll wait on that one. Let's try the button. Okay. The button, I actually, just to prove the case, I haven't even opened the case yet. So what happens with these guys is the battery operated ones have a little sticky thing, or a little ribbon, and that basically activates the battery inside. And then you'll see little lights flashing and stuff, meaning it's talking. And then clicking this will trigger the Zigbee dongle to go off and look at all the Zigbee clusters and all this RF stuff on the Zigbee stack. And then when it finds something, it'll show you this big, long hieroglyphic string. And then we just call it what we want, like a button. And done. And here's our button. It worked. So the button has actually 3 modes: a single press, a double press, and then a long press. And then it, rather than being a property like a switch, it actually generates events. So these events are now basically. And the cool thing is then I could set up, like when I set up in my demos, a single press turns on one light, and a double press turns off the light. A long press will turn on all the lights, but a double press still turns off all the lights. So those are set up with rules, so that makes it kind of fun. And then there are dimmer switches and other things that have even more stuff going on. So these guys are useful. I still don't know why this door sensor doesn't work. Something wrong. That was working earlier. And then, again, just on the preview, let's use voice. So the default wake word for the voice controller, I'll just show you quickly. How all of these things get added on is there's all these add-ons to bridge things that aren't native web things. And I'll show you how you discover new add-ons. And then you go to basically GitHub, and you can see the READMEs for all these different things. And so I was going to scroll down, and a couple new ones that one of our developers just made was the email sender and a Twilio adapter so that you could send notifications, because I was complaining how iPhones don't allow browser notifications, which is the kind of what we built in. And then the other thing is this one right here might work for that EAL thing, the generic sensors adapter, or the GPIO, because this one, when you add it, you can address the actual IOs. The whole HomeKit spec is in there, so if it says it's HomeKit compatible, it should work, but we haven't tested everything. So if we scroll down to voice control, oh, yeah, I just was showing you that we have all this stuff. And then once you add the things, then you have the page with configuration. And right here, the default wake word is Mozilla Gateway. And I should be able to use that to talk to it. Let's try. Mozilla Gateway, turn on the kitchen. So that's local. And then how you train the gateway. So the gateway is actually trained to my voice. So Tom, I'd like you to say that same.
Okay, Mozilla Gateway.
How about Emily?
Mozilla Gateway. Nope.
Mozilla Gateway. No. Mozilla Gateway. Turn on the switch. Yeah, the only thing I've noticed is that if I use a like higher voice or lower voice, like it really is trying to be tuned to my voice.
And you prompt it and I'll say turn off.
Well, I want to show you how this works. Is actually it works. Let me turn it up a little bit, the volume. How this works is that you train it 3 times. So first I'm going to change the wake word to something else. Let's call it New Zealand. Wait.
So Kathy, I propose you get Zane down here.
Yeah. Well, so that's the beauty of it, is how you speak, even if you speak with an accent. Some of you, I hear a lot of funny. So what happens with the voice controller is it's a thing, because this is how we can train it. So let's say.
Now let's train your wake word. After I stop talking, you'll hear 3 bips. Say your wake word right after each bip. You'll have 2 seconds to say it. It's important to do this in a very quiet room. If you are not ready yet, or want to stop the training, just push the voice controller button in the Gateway homepage to turn it off. Let's start recording. Here comes the first beep.
New Zealand. New Zealand. New Zealand. So it's successful if it does it 3 times. If it keeps beeping at you, like I was trying to do this in a conference and loud space and it just kept beeping at me, meaning like it wasn't getting quiet enough voice. So you really do have to go hide out in a quiet enough space to retrain it. Then it's retrained, and things, I don't know if I showed you, but when you add new words, basically it's got a local dictionary of words. And so when you add new things, or if I change the name of the thing, like if I change, let's do that for an experiment. If I change the name of the kitchen to den, then the local dictionary then has to change to something else. So let's see if it gets my new wake word. It takes a few seconds to train it. New Zealand, turn the den to blue. So again, this was supposed to be a teaser, but it takes a little while. All right, so now you have the local things where you show how you bring new things into your home and set them up. And I've gone so far as to now started giving Christmas presents to family and setting up my mom's house and my aunt's house in Minnesota and North Dakota. It's kind of fun. You can actually, mere mortals can actually use this if you can get someone to set it up for them. And so that's the beauty of all of you, is you shouldn't have any trouble setting this up. And so then the next thing I was going to do is go on to a new gateway setup. Get this stuff out of the way. Does anyone have any questions so far on the basics? Because there's a whole bunch of extra stuff. In fact, I should probably give you a few more quick hints on what goes on under the hood here. Where's my mouse? There it is. OK. So over here, also the Smart Assistant, the local voice controller is not hooked into this yet. One of our developers is working on it. But if I can say, when you type commands, they're also local. They don't go to the internet. So I can say, turn the den to green. And it should turn the den to green. You can also click and add voice. So that's what the Smart Assistant is. And the idea in the long run is the gateway would run on a Wi-Fi router, but those are usually in basements and closets and often different places. So then you would have other devices that are smart speakers that are being processing data locally, because your dictionary of IoT verbs and names of things and so forth is something that can be processed locally. So that's kind of the future that we envision. And then you still have smart assistants that query weather and stuff like that. They'll go to the internet. So that's the Smart Assistant. It's still experimental. Rules. So here's where we want to set up a rule and have something like a, so home automation is really helpful when you have a clock and set things, lights to go on and off at different times, making it appear someone's home or not, or turning them off when no one's around. But for example, a wireless button is just one of my favorite things, where if I set this event to pressed, I want to turn on the den, and den on. This is just it's just a rules engine that we set up as part of the app. I don't think there's anything fancy going on underneath. And then I want another one where I'll use the button again, and I'll do a double press, and I'll turn the den off. And then I could do a long press to change the color, stuff like that. So den off. And so now you have some base. And rules allow multiple inputs and multiple outputs. That's how I had a red LED change the rainbow of all the others. I just had red change as input and all the others as the output. So now, if I push the button, the den goes on. And if I double press, the den goes off. So, I mean, why have wall switches anymore? And once you had a TV remote, did you ever go up to the TV and turn the knob again?
When I lost the remote.
So, I mean, and some of the dimmer switches made have little magnets, so you can actually stick it to the wall, but like this. But you can move it with it too. So that's kind of cool. Supposedly years. I mean, I've had one of these for months, a few months. So supposedly they'll last for quite a long time. And they're getting better. I was talking to a low power Bluetooth company in the Bay Area that has basically mechanical buttons can produce enough energy to transmit the data because there's so little data that you really, they're virtually endless. You don't need even to have batteries, which is kind of cool. Let's see, so that's the rules really quickly. The floor plan is you upload a floor plan to your device. Do I have something? It's just. You can draw it and take a picture of it. The fancy people do SVG with a blue background. That's how we get the pretty ones. But basically, it's you upload the floor plan and then you drag and drop your stuff onto the floor plan. And I think my floor plan is still uploading. Yeah, you just upload a picture. Yeah, I've talked to some of the virtual, I mean, our end goal is like you go around with those VR or augmented reality painters, and you would basically walk around your home and you would create a 3D model of your home, and then you position things where they are. That would be, because then you can wear your augmented reality glasses and you can see where the smart things are to control and see what their names are. Okay, so that's the floor plan. Settings, the domain is something you install. An SSL certificate as part of the setup process. I'll show you that in a moment. And thereafter, you can add as many users as you want. Add-ons, I showed you, that shows the adapters. The updates come quarterly over the air. This is the 0.7 pre-release. Authorizations is how the third-party services work. And I have this one authorization for the voice control is actually a third party because it's not meant to necessarily be on our router. It's a separate box, even though I'm running them both on the same box right now. The voice controller could be a separate box. And so it's using the secure web token to talk to the gateway to set the web thing API. Experiments, that's the smart assistant. And then the developer mode is basically you can enable SSH just through this checkbox. But when you do that, SSH in and change your password. View logs is, the logs are pretty beefy. And then the create local authorization, I'll just show you how that works. You can decide monitor and control or just monitor, and eventually it should be more fine-grained. One of the next things we're doing is logging so that people will see, be able to see and understand the data that they're sharing with a third party before they actually share it. Because it's very important. People think, you know, turning things on and off are why do I need privacy? You need privacy because all of your habits add up to when you're home or not, or if you have latchkey kids that are home before you and all those things. So be very careful about that. But what happens is you determine what you need to share, and then we were kind enough to put a whole bunch of examples with the token built into it, and so you go copy paste. And Emily, she'll come up here and she'll grab the Rust example. All right, so that, in a nutshell, gives us an existing, go back. And I don't know if there's anything else in the other ones that's interesting. You know, this is an IKEA light. It's got brightness and color temperature, so warm and cold. The properties, the web thing API is on iot.gateway.org/schemas is all the ones we've published so far. And the ones in this release, we just added temperature sensors, leak detectors, and the camera support, camera and video. I don't think there's any other stuff. And oh, I might as well turn these guys off. This just shows like the heart rate sensor is set at 60 beats per minute. The distance sensor is pointing from my desk to the ground, and so it's 78 centimeters. You can see those types of data. These are custom things, and you can put custom icons on them. This is kind of cool. This is actually the Circuit Playground Express from Adafruit, and you can, if I turn it on right now and there's somebody in the office, they'll be really annoyed because it goes dee 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 dee. It's loud and it's bright, and I try not to do that unless I'm standing there. So yeah, so that's basically these. Now let's must be a website. Now let's do something like bring up a new one. Or before I bring up a new one, because this could take a little time, I think I'm going to skip back over to the slides and walk you through that part first. So let me just skip through here. So again, today we've been doing it for the last year, just install on a Raspberry Pi, or you can just install the gateway as per the documentation on GitHub on your laptop. Most of the developers just run it on their laptop and keep up to date with cloned copies. So you can run it on, as far as I know, Windows, Mac, and Linux for that. And so that's been the paradigm where you plug in these dongles. Now in the next phase this year, what we really want to do is replace the Raspberry Pi with a router. Because if we're in a central point of the home, we can protect not just the privacy, but also the network security, become a certificate authority of some sort. There's a bunch of ideas floating around for how we could have your personal browser accept certificates for your personal devices. Again, some way of taking ownership of your devices, not having vendors have ownership of your devices. And so you can still plug in dongles to get other radios, and with routers, you might have to add a Bluetooth dongle, although there are some routers coming out more IoT gateway ready. And then some of the routers, we've got our packages already upstream to OpenWRT. We've been doing that. And the problem with most of the cheap routers is there's not enough memory on both sides, not enough RAM and not enough flash. But now some of the beefier routers can have the processing power and RAM capability, but oftentimes they still don't have the flash space. So you can plug in a USB dongle and get extra space that way. So that's our goal for the year. So you still can buy commercial off-the-shelf stuff. And actually, the Home Assistant, Paulus, is trying to bridge in the WebThing API so that we would be compatible. We would love to see more projects that are compatible with the WebThing API. That's what we're doing through the W3C. And then I just wanted to mention from a security standpoint, after you get the Raspberry Pi on your network, either Ethernet or Wi-Fi, the very first thing it has you do is assign a subdomain. So this just fetches a certificate from Let's Encrypt, assigns it to your own email address, and you then own that subdomain. So it's time to grab your name as a subdomain. Now this is potentially temporary in the sense that this is so that we can tunnel in through a firewall and you can access your data remotely. But it is an important step. And then what we're doing with the Web of Things is basically you have all these different protocols and all these different URLs linking together different systems using the web as a discovery. So the way I see it, there's this W3C layer that bridges things at the web, and then you determine what goes up to the cloud. All of our product development stuff goes on as issues, mostly under the Gateway repository, with all the add-on lists, and everything is publicly available on Mozilla-IoT. We chat on Mozilla's IRC server on the hashtag IoT channel. We have an IoT channel on Discourse. And again, we post issues. And we also have an IoT at Mozilla.com email distribution that hits our team. We did a user study that the results are being discussed in a meeting tomorrow. But in a nutshell, it was hard for people to if they couldn't figure out how to, well, the main issue we ran into is that Windows 10 doesn't resolve gateway.local in the browser, and it's something weird with their networking stack. Like even ping gateway.local doesn't work. You have to say ping space -4 space gateway.local, and that's how you can get it. So all these things were a little bit annoying that we weren't really prepared for the home networking aspects. But the user study was kind of fun, and mostly what we found out is people liked the home automation, they liked the sensors, and they wanted cameras to know, like, wait, that sensor went off and I'm at work, but is it really, you know, what's really going on? And so having some sort of visibility. So I'm just going to flip through these UI slides pretty quick, since we've already seen some of this. You have sensors and actuators. In fact, this is what the door open is supposed to look like, and the motion sensors. The floor plan, push buttons, like I say, I consider them like TV remotes. They're really useful. And you can have, you know, if, and, or outputs. It's a pretty flexible rules engine. And so you can have multiple ins and multiple outs. And the Smart Assistant lets you set basically any properties of the device you can set, because it has a name of it. So again, enabling devices on the web is not the same as enabling devices to the cloud. That's the important thing to tell all your friends, the important thing that we're trying to teach here. So now I was going to do a little demo stuff. Well, let's see. We have, what time is it? What time is the? Yeah, but some people wanted to sneak out for the next talk.
5 minutes.
Yeah, OK. So microblocks.fun. If you want to take part in the second phase of this operation, because I might skip this gateway setup and do that at the end just to make sure we can get started with the fun part. But microblocks.fun, it's still an alpha, considered an alpha release, but you shouldn't have any problem with it. What happens is you download this IDE, and for both Mac and PC and Linux, you probably will run into it's not an authorized developer whatever app, and so you have to go into security settings and open it anyway. You've downloaded something from the internet. So if you want to play with some hardware, download from microblocks.fun. There's a download information that describes how to do that. And then what we will do is, because all of these ESP32 devices have Wi-Fi, our blocks will say something like Wi-Fi connect to Mozilla thing. I have a router here, and it also works to connect to the Linux conf thing. So I'll do a demo quick. In fact, why don't we do the demo right now so that those of you who have to leave can still see it. Yeah. Oh, when you boot up the Pi, the first page, it asks for the subdomain. The second page is a new user account, and then splat, you're done.
So it's not something you go to with.
No. Just the Pi serves it up. The Pi, then you put in the name, and if somebody already took it, it will say it's taken, and you have to fetch another one. But let's try this. OK. So what we're going to do is I'm going to show you if you download microblocks. Oh, microblocks does a really bad job of moving to a new window. I don't know if it's going to work or not. I might have to bear with me. I might have to. I think I have to mirror first. Yeah, stop. Force quit. Let's see, settings. will it work now? Okay, now let's try this. I've got my IoT bus kit, LED example, and I'm going to put in all right, and I connect to the board with the connect button, and that little button turns green. I've pre-flashed the virtual machine on all of these because with the microbit and some of the other Adafruit Circuit Playground, they have a built-in virtual machine that can be flashed to the device. You plug in a brand new board, and first time it asks you, do you want to install the virtual machine? You say yes, and it does it. These ones you have to use the ESP tool, which is described on the website. So what we've got here is we've got, what happens is the virtual machine, the blocks are in it, and then you have to click the start button to actually start it and run it. And so what it will do is it tries first to get, to connect to the Wi-Fi, and it gets an IP address, 10.193.6.173. Now, it's, what we'd like, the next phase of these blocks is to do that over MDNS so that it would be like, take the name of my LED dot something, but right now instead with the things gateway, actually you have to put that address in here. So we're going to do 10.193, was it? .6.173. 6.173.
You've got 76.
Oops.
There you go, 6.
Okay. So what you do is you submit that, and then the properties of the thing are known because that's what it is. And then I say done. And now I have a LED thing. And I should be able to say, New Zealand, turn on the LED. And I don't know if I waited long enough for it to retrain the dictionary. Let me try turning it on. So as you can see, it didn't take me too long. And with MDNS, it would even be easier. So what happens is, I just want to show you, if you remember that IP address, 10.193.6.173, was that it? That's my thing. That's why it's called a web thing. And so basically these things are addressable as web things. And then even in the microblocks, it's kind of cool because if I stop this and I click on my little thing description was one of the advanced blocks, although it's not nicely formatted, it basically shows you how it's describing this thing as a web thing. And these web things also, just going back to the website, iot.mozilla.org/schemas. Yeah, so if you have to go ahead and go, but this is where you can find all the things that are defined, and then as we add to this list, they'll be added to microblocks so you can do those things. So we'll take a quick pause and let people escape. And too bad for you, because the rest of the people get to play. Scroll down, and a couple new ones that one of our developers just made was the email sender and a Twilio adapter so that you could send notifications, because I was complaining how iPhones don't allow browser notifications, which is the kind of what we built in. And then the other thing, this one right here might work for that EAL thing, the generic sensors adapter, or the GPIO, because this one, when you add it, you can address the actual IOs. The whole HomeKit spec is in there, so if it says it's HomeKit compatible, it should work, but we haven't tested everything. So if we scroll down to voice control. Oh, yeah, I just was showing you that we have all this stuff. And then once you add the things, then you have the page of configuration. And right here, the default wake word is Mozilla Gateway. And I should be able to use that to talk to it. Let's try. Mozilla Gateway, turn on the kitchen. So that's local. And then how you train the gateway. So the gateway is actually trained to my voice. So Tom, I'd like you to say that same.
Okay. Mozilla Gateway.
How about Emily?
Mozilla Gateway. Nope.
Mozilla Gateway. No. Mozilla Gateway. Turn on the switch. Yeah, the only thing I've noticed is that if I use a like higher voice or lower voice, like it really is trying to be tuned to my voice.
And you prompt it and I'll say turn off.
Well, I want to show you how this works. Is actually it works. Let me turn it up a little bit, the volume. How this works is that you train it 3 times. So first I'm going to change the wake word to something else. Let's call it New Zealand. Oh, wait.
So Kathy, I propose you get Zane down here.
Yeah. Well, so that's the beauty of it is how you speak, even if you speak with an accent. Some of you, I hear a lot of funny. So what happens with the voice controller is it's a thing, because this is how we can train it. So let's say.
Now let's train your wake word. After I stop talking, you'll hear 3 bips. Say your wake word right after each bip. You'll have 2 seconds to say it. It's important to do this in a very quiet room. If you are not ready yet, or want to stop the training, just push the voice controller button in the Gateway homepage to turn it off. Let's start recording. Here comes the first beep.
New Zealand. New Zealand. New Zealand. So it's successful if it does it 3 times, if it keeps beeping at you, like I was trying to do this in a conference in a loud space and it just kept beeping at me, meaning like it wasn't getting quiet enough voice. So you really do have to go hide out in a quiet enough space to retrain it. Then it's retrained and things, I don't know if I showed you, but when you add new words, basically it's got a local dictionary of words. And so when you add new things, or if I change the name of the thing, like if I change, let's do that for an experiment. If I change the name of the kitchen to den, then the local dictionary then has to change to something else. So let's see if it gets my new wake word. It takes a few seconds to train it. New Zealand, turn the den to blue. So again, this was supposed to be a teaser, but it takes a little while. All right, so now you have the local things where you show how you bring new things into your home and set them up. And I've gone so far as to now started giving Christmas presents to family and setting up my mom's house and my aunt's house in Minnesota and North Dakota. It's kind of fun. You can actually, mere mortals can actually use this if you can get someone to set it up for them. And so that's the beauty of all of you is you shouldn't have any trouble setting this up. And so then the next thing I was going to do is go on to a new gateway setup. Get this stuff out of the way. Does anyone have any questions so far on the basics? Because there's a whole bunch of extra stuff. In fact, I should probably give you a few more quick hints on what goes on under the hood here. Where's my mouse? There it is. Okay. So over here, also the Smart Assistant, the local voice controller is not hooked into this yet. One of our developers is working on it. But if I can say, when you type commands, they're also local. They don't go to the internet. So I can say, turn the den to green. And it should turn the den to green. You can also click and add voice. So that's what the Smart Assistant is. And the idea in the long run is the gateway would run on a Wi-Fi router, but those are usually in basements and closets and often different places. So then you would have other devices that are smart speakers that are being processing data locally, because your dictionary of IoT verbs and names of things and so forth is something that can be processed locally. So that's kind of the future that we envision. And then you still have smart assistants that query weather and stuff like that. They'll go to the internet. So that's the smart assistant. It's still experimental. Rules. So here's where we want to set up a rule and have something like a, so home automation is really helpful when you have a clock and set things, lights to go on and off at different times, making it appear someone's home or not, or turning them off when no one's around. But for example, a wireless button is just one of my favorite things, where if I set this event to pressed, I want to turn on the den, and den on. This is just it's just a rules engine that we set up as part of the app. I don't think there's anything fancy going on underneath. And then I want another one where I'll use the button again, and I'll do a double press, and I'll turn the den off. And then I could do a long press to change the color, stuff like that. So den off. And so now you have some base. And rules allow multiple inputs and multiple outputs. That's how I had a red LED change the rainbow of all the others. I just had red change as input and all the others as the output. So now, if I push the button, the den goes on. And if I double press, the den goes off. So, I mean, why have wall switches anymore? And once you had a TV remote, did you ever go up to the TV and turn the knob again?
When I lost the remote.
So, I mean, and some of the dimmer switches have little magnets, so you can actually stick it to the wall, but like this. But you can move it with it too. So that's kind of cool. Supposedly years. I mean, I've had one of these for months, a few months. So supposedly they'll last for quite a long time. And they're getting better. I was talking to a low-power Bluetooth company in the Bay Area that has basically mechanical buttons can produce enough energy to transmit the data, because there's so little data that they're virtually endless. You don't need even to have batteries, which is kind of cool. Let's see. So that's the rules really quickly. The floor plan is you upload a floor plan to your device. Do I have something? It's just. You can draw it and take a picture of it. The fancy people do SVG with a blue background. That's how we get the pretty ones. But basically, you upload the floor plan, and then you drag and drop your stuff onto the floor plan. And I think my floor plan is still uploading. Yeah, you just upload a picture. Yeah, I've talked to some of the virtual, I mean, our end goal is like, you go around with those VR, or augmented reality painters, and you would basically walk around your home, and you would create a 3D model of your home, and then you position things where they are. That would be, because then you can wear your augmented reality glasses, and you can see where the smart things are to control, and see what their names are. Okay, so that's the floor plan. Settings, the domain is something you install, an SSL certificate as part of the setup process. I'll show you that in a moment. And thereafter, you can add as many users as you want. Add-ons, I showed you, that shows the adapters. The updates come quarterly over the air. This is the 0.7 pre-release. Authorizations is how the third-party services work. And I have this one authorization for the voice control is actually a third party, because it's not meant to necessarily be on our router. It's a separate box, even though I'm running them both on the same box right now. The voice controller could be a separate box. And so it's using the secure web token to talk to the gateway to set the web thing API. Experiments, that's the smart assistant. And then the developer mode is basically you can enable SSH just through this checkbox. But when you do that, SSH in and change your password. View logs is, the logs are pretty beefy. And then the create local authorization, I'll just show you how that works. You can decide monitor and control, or just monitor, and eventually it should be more fine-grained. One of the next things we're doing is logging so that people will see, be able to see and understand the data that they're sharing with a third party before they actually share it. Because it's very important. People think, turning things on and off, why do I need privacy? You need privacy because all of your habits add up to when you're home or not, or if you have latchkey kids that are home before you, and all those things. So be very careful about that. But what happens is you determine what you need to share, and then we were kind enough to put a whole bunch of examples with the token built into it, and so you go copy paste, and Emily, she'll come up here and she'll grab the Rust example. All right, so that, in a nutshell, gives us an existing, go back. And I don't know if there's anything else in the other ones that's interesting. This is an IKEA light. It's got brightness and color temperature, so warm and cold. The properties, the web thing API is on iot.gateway.org/schemas, is all the ones we've published so far. And the ones in this release, we just added temperature sensors, leak detectors, and the camera support, camera and video. I don't think there's any other stuff. And I might as well turn these guys off. This just shows like the heart rate sensor is set at 60 beats per minute. The distance sensor is pointing from my desk to the ground, and so it's 78 centimeters. You can see those types of data. These are custom things, and you can put custom icons on them. This is kind of cool. This is actually the Circuit Playground Express from Adafruit. And you can, if I turn it on right now and there's somebody in the office, they'll be really annoyed because it goes dee, 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 dee. It's loud and it's bright, and I try not to do that unless I'm standing there. So yeah, so that's basically these. Now let's, must be a website. Now let's do something like bring up a new one. Or before I bring up a new one, because this could take a little time, I think I'm going to skip back over to the slides and walk you through that part first. So let me just skip through here. So again, today we've been doing it for the last year, just install on a Raspberry Pi, or you can just install the gateway as per the documentation on GitHub on your laptop. Most of the developers just run it on their laptop and keep up to date with the cloned copy. So you can run it on, as far as I know, Windows, Mac, and Linux for that. And so that's been the paradigm where you plug in these dongles. Now in the next phase this year, what we really want to do is replace the Raspberry Pi with a router. Because if we're in a central point of the home, we can protect not just the privacy, but also the network security, become a certificate authority of some sort. There's a bunch of ideas floating around for how we could have your personal browser accept certificates for your personal devices. Again, some way of taking ownership of your devices, not having vendors have ownership of your devices. And so you can still plug in dongles to get other radios, and with routers, you might have to add a Bluetooth dongle, although there are some routers coming out more IoT gateway ready. And then some of the routers, we've got our packages already upstream to OpenWRT. We've been doing that. And the problem with most of the cheap routers is there's not enough memory on both sides, not enough RAM and not enough flash. But now some of the beefier routers can have the processing power and RAM capability, but oftentimes they still don't have the flash space. So you can plug in a USB dongle and get extra space that way. So that's our goal for the year. So you still can buy commercial off-the-shelf stuff. And actually, the Home Assistant, Paulus, is trying to bridge in the WebThing API so that we would be compatible. We would love to see more projects that are compatible with the WebThing API. That's what we're doing through the W3C. And then I just wanted to mention from a security standpoint, after you get the Raspberry Pi on your network, either Ethernet or Wi-Fi, the very first thing it has you do is assign a subdomain. So this just fetches a certificate from Let's Encrypt, assigns it to your own email address, and you then own that subdomain. So it's time to grab your name as a subdomain. Now this is potentially temporary in the sense that this is so that we can tunnel in through a firewall and you can access your data remotely. But it is an important step. And then what we're doing with the Web of Things is basically you have all these different protocols and all these different URLs linking together different systems using the web as a discovery. So the way I see it, there's this W3C layer that bridges things at the web, and then you determine what goes up to the cloud. All of our product development stuff goes on as issues, mostly under the Gateway repository, with all the add-on lists, and everything is publicly available on Mozilla-IoT. We chat on Mozilla's IRC server on the hashtag IoT channel. We have an IoT channel on Discourse. And again, we post issues. And we also have an IoT at Mozilla.com email distribution that hits our team. We did a user study that the results are being discussed in a meeting tomorrow. But in a nutshell, it was hard for people to, if they couldn't figure out how to, the main issue we ran into is that Windows 10 doesn't resolve gateway.local in the browser, and it's something weird with their networking stack. Like even ping gateway.local doesn't work. You have to say ping space -4 space gateway.local, and that's how you can get it. So all these things were a little bit annoying that we weren't really prepared for the home networking aspects. But the user study was kind of fun, and mostly what we found out is people liked the home automation, they liked the sensors, and they wanted cameras to know, like, wait, that sensor went off and I'm at work, but is it really, what's really going on? And so having some sort of visibility. So I'm just going to flip through these UI slides pretty quick, since we've already seen some of this. You have sensors and actuators. In fact, this is what the door open is supposed to look like, and the motion sensors. The floor plan. Push buttons, like I say, I consider them like TV remotes. They're really useful. And you can have, if, and, or outputs. It's a pretty flexible rules engine. And so you can have multiple ins and multiple outs. And the Smart Assistant lets you set basically any properties of the device you can set, because it has a name of it. So again, enabling devices on the web is not the same as enabling devices to the cloud. That's the important thing to tell all your friends, the important thing that we're trying to teach here. So now I was going to do a little demo stuff. Well, let's see. We have, what time is it? What time is the? Yeah, but some people wanted to sneak out for the next talk.
5 minutes.
Yeah, okay. So microblocks.fun. If you want to take part in the second phase of this operation, because I might skip this gateway setup and do that at the end just to make sure we can get started with the fun part. But microblocks.fun, it's still an alpha, considered an alpha release, but you shouldn't have any problem with it. What happens is you download this IDE, and for both Mac and PC and Linux, you probably will run into it's not an authorized developer whatever app, and so you have to go into security settings and open it anyway. You've downloaded something from the internet. So if you want to play with some hardware, download from microblocks.fun. There's a download information that describes how to do that. And then what we will do is, because all of these ESP32 devices have Wi-Fi, our blocks will say something like Wi-Fi connect to Mozilla thing. I have a router here, and it also works to connect to the Linux conf thing. So I'll do a demo quick. In fact, why don't we do the demo right now so that those of you who have to leave can still see it. Yeah. Oh, when you boot up the Pi, the first page it asks for the subdomain. The second page is a new user account, and then splat, you're done.
So it's not something you go to what?
No. Just the Pi serves it up. The Pi, then you put in the name, and if somebody already took it, it will say it's taken, and you have to fetch another one. But let's try this. Okay, so what we're going to do is, I'm going to show you if you download Microblocks. Oh, Microblocks does a really bad job of moving to a new window. I don't know if it's going to work or not. I might have to, bear with me. I might have to, I think I have to mirror first. Yeah, stop. First quit. Let's see, settings. Display. Okay. Will it work now? Okay, now let's try this. I've got my IoT bus kit, LED example, and I'm going to put in all right, and I connect to the board with the connect button, and that little button turns green. I've pre-flashed the virtual machine on all of these because with the microbit and some of the other Adafruit Circuit Playground, they have a built-in virtual machine that can be flashed to the device. You plug in a brand new board, and first time it asks you, do you want to install the virtual machine? You say yes, and it does it. These ones you have to use the ESP tool, which is described on the website. So what we've got here is we've got, what happens is the virtual machine, the blocks are in it, and then you have to click the start button to actually start it and run it. And so what it will do is it tries first to get to connect to the Wi-Fi, and it gets an IP address, 10.193.6.173. Now, it's what we'd like, the next phase of these blocks is to do that over MDNS, so that it would be like, take the name of my LED dot something, but right now instead with the things gateway, I actually have to put that address in here. So we're going to do 10.193, was it? .6.173. 6.173.
You've got 76.
Oops.
There you go, 6.
Okay. So what you do is you submit that, and then the properties of the thing are known because that's what it is. And then I say done. And now I have a LED thing. And I should be able to say, New Zealand, turn on the LED. And I don't know if I waited long enough for it to retrain the dictionary. Let me try turning it on. So as you can see, it didn't take me too long. And with MDNS, it would even be easier. So what happens is, I just want to show you, if you remember that IP address, 10.193.6.173, was that it? That's my thing. That's why it's called a web thing. And so basically, these things are addressable as web things. And then even in the microblocks, it's kind of cool because if I stop this and I click on my little thing description was one of the advanced blocks, although it's not nicely formatted, it basically shows you how it's describing this thing as a web thing. And these web things also, just going back to the website, iot.mozilla.org/schemas. Yeah, so if you have to go ahead and go, but this is where you can find all the things that are defined, and then as we add to this list, they'll be added to microblocks so you can do those things. So we'll take a quick pause, and yeah, so while we're writing names, let me just jump back briefly over here to the framework. We're going to go on to this shows you how things are discovered, added to your gateway. I also wanted to say that I'm actually, the microblocks.fun is a project under the Software Freedom Conservancy. And they just got accepted the SFC as about a month or two ago. And I'm on their board of advisors. And then I've been using it in volunteer settings in schools. And this little Christmas tree on the right was a project we did with East San Jose, sort of the underprivileged schools of the San Jose area, where kids from 3rd to 5th grade learn to program the NeoPixels on these snow pixels and using microblocks. And then the pixels were on display so each kid got their own to put on Christmas trees that were decorated by 5 schools. And then we had, in the upper image, we had these giant 4-foot by 4-foot snowflakes where we would rotate. I connected them all. They don't have wireless. They're just a Adafruit itsy bitsy on the back. And so I connected them all over serial USB, all 36 of them, and ran the gateway to change to a different student pattern every minute. So then the student patterns would play. And then we also had a mode where we could switch it in following music mode using some other hardware. So that was a fun project, and my goal for next year will be to teach the kids using microblocks to do a gesture-based device like the microbit and the circuit playground. They have these XYZ accelerometers, so they could program a gesture and then walk up to the tree and do their gesture to change all of the pixels, the snow pixels on the tree to their pattern. It'd be kind of fun. So That's one of the real benefits of working on open source that I absolutely love is I can do a lot of things of giving back with our technology.
Just wondering if you are also talking to people like the Pi Foundation with the Code Club, because the owners of the Code Club now, you could get a huge build market. That, because I run a Code Club and we would fall over ourselves to be buying this instead of the proprietary stuff.
I think it would make a fabulous classroom kit where you get basically a Raspberry Pi and then a whole bunch of, where's my stash of other boards? You get a whole bunch of wireless or wired things, but wireless would be even better. Basically, we've got these microbits that, this is an NRF51, and there's not enough space to run a full Bluetooth stack and the virtual machine for them, but if we ran the make code, sort of not just use the Bluetooth radio, but not a full stack, these would be great devices. And then you'd have these things wirelessly talking to this. So you'd have a bridge of this sort of the low-level protocol, and then you'd be able to control them all through the gateway. So you have one Raspberry Pi and then a whole classroom full of microcontrollers.
A little bit about gateway software and what components are made up of and stuff like that. Like I understand,
Yeah.
Raspberry Pi.
So the Raspbian Lite image is our base, and then we also have it ported to OpenWRT. You can run it on any other Linux distro, Debian, whatever. So we're running on Raspberry Lite, and the add-ons are separate. So the main gateway application is written on Node, but all of the add-ons can be written in Rust, Python, Java, JavaScript, blah, blah, blah. And then also, the things can be programmed in anything you want, because they just have to somehow produce JavaScript at the end of the day. Or the wired ones or wireless other protocols, they get an add-on on the gateway that bridges them into becoming a web thing. So.
Like assuming we've got a Raspberry Pi on 3 or something.
Yeah.
What's the fastest way to get up and running?
Fastest way is to, if you go to iot.mozilla.org.
There's also a Docker image.
Yeah, there's a Docker image, and you click the gateway page. Today, this download image is 6.1, and tomorrow it should be 0.7. And you click that. You flash it if you've ever used, I use Etcher to flash the images, or you can go over to that little station over there. Basically, you can, yeah. So you flash the image, you stick it in there, and then that was what I was going to do. In fact, maybe I'll just plug this in so that I can demonstrate how that works. Because for a classroom or something, you would just do that once. Never see these guys. First time that it boots up, it usually takes a few minutes because it's unpacking and uncompressing and filling up the disk space. But yeah, you get and then you, with or without dongles, depending on your extra radios. So the things, if you go to the things page on our website, it shows how to install and examples in different languages. So, how to do things in Python, how to do things in Java, how to do things in Rust. So it has the same example in all these different languages. How to do things in Arduino. We have Arduino libraries. Whoops. Right here. And I don't know how many of you program in the Arduino framework. I also use Platform.io extension on VS Code. The IoT bus, this whole kit has examples that you can just git clone into Platform.io, and they will build, and they have full debugging and so forth. There's this Moddable SDK, which is a JavaScript SDK, and they have support for, there's a display TFTP touchscreen display that goes along with this ESP32, in fact, the IoT bus, and then you can have touchscreen interfaces that are local, that are then tied essentially as web things to your gateway. So that's always nice. People don't like it when the only way to do stuff is to, if I'm at home, yeah, and I pull up my cell phone and I pull up my little icon. So it's a progressive web app, the gateway is, and so it isn't a separate app, but you can add to home screen so that it looks like an app. And from here, this is my house, I can control it. But if you're actually at home, you either want like physical buttons or use your voice, or if it's an appliance, a little fancier user interface, you might want to have a local touchscreen, as well as be able to know the status of things when you're not standing in front of it. So that's, like I say, the website gateway things, the web thing API, we're working through the W3C, and then the hidden URL basically is, or maybe it's from this page, schemas. Do we, yeah, yeah. Yes, there's the, oops, wrong one. There's a weather add-on for, oops, wrong, did the wrong thing, called Netatmo, I think it is. Yeah, Netatmo weather station. So if you add that, just like there's that 8 LED blinked array, that was what I was doing the rainbow with. That's just a blinked, Pimoroni blinked array, and somebody wrote an add-on for it, so I didn't even have to do any GPIO configuration. I just installed the add-on, and I have 8 lights, so it's kind of fun. Yeah, so these are the add-ons that people have built, and you can see who's built them and the link to their GitHub, which might have more information if they're complex. Yeah, so some of these, obviously, you have to acquire the right hardware. And then under our wiki that you can get from GitHub, we have a supported devices list. It's hard to maintain that, but we'll try to get better at maintaining that. Let's see, where was I? Back here. So this project, local voice enablement, I showed you that already. This is the things in different languages. Properties, actions, and events. Properties are the most common thing, but actions is something like if something that needs to go over a period of time and end up in a different state, like a blind closing, like close the blinds to 50% out of this degrees, or something complex more than just a simple property. Or a fade action, fade to 50% over 2 seconds for lighting. And then events, you saw push buttons and stuff are events, and then there could be other events that trigger notifications. So already there's quite a few examples that fit our web thing API. Like I say, here's a bunch of the add-ons that people have built, and there might be more. They can be submitted. This is the Oddwires kit that Tom, you're helping prepare the. Or are they ready to be drawn?
Already.
Oh, it's all ready. So now we're going to draw for the kits and the boards, and I'll have to count the boards, but I'm willing to sell as many as people want one of the I/O boards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, although I might need 1, 12. Well, we'll see. All right, ready? Da-da-da. Serge. Serge. Okay. All right, so come on up and pick the one you want. Do you want a kit or a board? Okay. Kit. And the kit's, the I/O board has already got the virtual machine for microblocks on it, so you'll be able to play right away. Okay, Chris Rogers. Okay. Come on down. Do you want the kit? Okay. Okay. Jonathan. Aiden? Is that right? Tris? Tris Hetty? Kasara? Tris, which, are you Tris?
I'm Tris.
Okay, there's one more kit, or we can start taking boards.
I'll take the board.
Okay, do you want a specific sensor with it? The relay, the temp humidity, the door, the motion, and the distance.
Temperature.
Okay? Okay, you're Kasara?
Yep.
Okay. Which of the kit? Okay. All right. Zane. I mean, don't worry if you don't get a kit because these components are really standard. Like you can buy these presumably locally. So that there are no kits left, but unless you want me to try to package one, but yeah, they're kind of broken apart. So you can pick any board either with the relay, the temp humidity, door sensor, motion sensor, distance sensor. Distance sensor measures distance in centimeter with acoustic distance sensor.
Cool.
It's fun.
How much is it?
17 US. Roman? Okay, now I'm going to go faster. Bernie?
So it was IO board. Is that correct? Or is it-
Yeah, all these are IO boards,
Yep.
so
So just grab one.
just grab one. Yeah.
Okay. And that's just it. Cool.
This is temperature, right?
Yeah, temperature, humidity.
This one.
I mean, I'm letting people borrow. After we run out of the I/O boards, I have some more Node MCUs that we can play.
This one can switch AC.
Yeah, yeah. Okay. Did I get Bernie? Yeah, that's you. Okay. All right. Let's try to get you one. Let's see. Jake.
Can I take the instructions too?
Yeah. The instructions are actually online on GitHub, so I'll point you there in a second. Somebody's name got cut off. Lewis. Brian Hollister. Satoshi. Dave Lane. Okay, well, I'll keep one for him. Well, actually, I have one up there. I'll keep one for him, and then I'll just let him know. Uday.
You still have the door sensor?
Yeah, these are door sensors.
Right. Just take one?
Yeah, take one, but you want don't you want the IoT bus?
Yeah.
Yeah, so these ones or just grab this one. And then if you want to hook up a door sensor, yeah, grab that. Matt Britton,
So this part.
that part,
Where's the
and then you would need
board?
just the board.
The other.
Yeah,
Most of them are plugged into
grab, so
something.
these two, I have my own sliders and things that I want to keep.
Yeah.
So just grab that and take the wires off of it. It's a
Sorry.
push button.
So
Ju-
grab-
Just here, I'll just take this off. All right. You want that and the I/O board?
Oh, yep.
Okay. Take off the slider.
Thank you.
All right. let's see. Wait, that was Alex? Alex Wiz? And James Lee? And I, oh, okay. Yeah, if you want to, there's the door sensor or the motion sensor if you want instead of the temp humidity.
I was mostly going to use it for some sequence, but
Yeah, so this will just let you play. You can bring the sensors back.
okay. Oh, I see. Yeah, okay. Well, in that case, I'm
These are
fine
just
with
a,
anything.
what's that?
I'm fine with anything to so.
Yeah, so just leave that connected. It's already there. Motion sensor, temp humidity, door sensor. Whoops. Okay, so if you have, whoops, if you have microblocks loaded, then if you go to my GitHub account, let's see. Again, from the website IoT Bus, if you want to get it with the Raspberry Pi, it adds $50, and you get the Pi, the case, the power supply, and a pre-flashed micro SD card. So literally, you just boot the thing into the gateway. Yes, these are all US. And again, just to wrap up, putting people first, that's Mozilla's goal, and we are going to add logging, but it would be local logging and local things, and I won't get into all the stuff. But like I said, our goal for a consumer protection of your home network would, in addition to the smart home, would add parental controls, network health add-ons. Basically, Mozilla help you take control of your privacy and security. And the big value proposition here is that, to me, IoT installments are still way too expensive. You buy these boxes, and what are you buying? You're buying app store apps, and you're buying cloud server maintenance. And if you think about what these companies have to do, there's a lot of overhead more than just this piece of plastic. And if we actually sold things that were just the piece of plastic with the little wireless radios, we all know that we can get these little Node MCUs for at least I can get them for $3 at AliExpress, right? So it's not like that's so expensive, it's that the whole rest of it is too expensive. But if you could buy one affordable one-off purchase of your gateway, and then things start coming down in price because they're just commodities of connectivity, it should get better. All right, so we're going to do, that's not the one I want. Thanks, gateway. Yeah, so you've all been to Microblocks. This is where you downloaded it. I've already done this ESP32 advanced setup, and basically what happens is you run a series of scripts after installing the Python, the ESP tool. And so cat./new. So in ESP32, these are the steps that flash it. And so I just do new ESP32, and I bring up a new board. And that's described on this page. You had a question? Yes. Oh, yeah. If you don't have micro USB cables, I went to our IT office, and I literally fetched every single one they had. So come and just grab one. I would like these back, though. I promised them I would bring them back.
I had one earlier today, so I should be able to find that.
I'll try and take it.
Oh, wow, that's
That,
a long one.
it is a,
I don't suppose you got any micro.
I don't have any adapters. I'm sorry. I keep an old school laptop on purpose for all this stuff. Okay, so that's Microblocks. I just wanted to show you that on Mozilla IoT, all these add-ons, like the Twilio adapter is very complex, but the description, James Hoban did this, and the description of how you can actually send yourself messages through Twilio and how you install it and everything are really well done. Andre is working on the voice controller write-up. We did some video recording. The blog's not out on that yet, but we'll be blogging some of these add-ons. Also the email sender, so you can get alerts that way. And it's nicely written up. And then not so nice is my own GitHub, Kjori, this IoT bus microblocks. And I've been scrambling and trying to get ready for this thing, but I have a draft of the examples that show, and I tried to wire up some of them late last night so that you didn't have to figure out the pins on your own. But some of the blocks of the example blocks have changed from this document. But essentially it tells you how you plug it in, you click the connect button to connect to the board, and then this little set user LED is something that should work right away. In fact, my board right here, once you get it plugged in, the set user LED is something you can just turn on. You just click the block and then I can set it to false and turn it off. So you can check that right away to make sure you have board connectivity. And then if you have a stacked relay thing, you would be looking under the relay. And then I have posted on this, and then in this document has a pinout chart. Stop. And then, more importantly, yeah, the wiring, so you can see what. And originally, I mapped things to pin 4 typically, but what I found out is when the Wi-Fi is enabled, that the sensors of the motion sensor, the door sensor, they don't use pin 4, actually use pin 39. Works much better. And so anyway, that's the PDF, and then in this, so the tools are in this folder, and the IoT bus kit has the application. So in order to get the applications for the type of sensor you have, you can hopefully read these. If you have the temp humidity sensor, go fetch that one. If you have the motion sensor, go fetch that one, so on and so forth. So like when in here, if I were to plug in a different board with my slider, I can unplug this one. Let me show you how the slider, so the light showed you how to actuate something, and now let's show how to sense something. And I would go here, I need to connect to that board. I already have it saved under my examples, so I'm gonna grab my slider. And you would download whichever one you want. And then the main thing is you're gonna have to put in Linux conf au. Yeah, don't publish it. I asked these guys, I told them I was gonna be typing, it's gonna be visible. They said it was okay. And then, yeah, so once you have it ready to go, you say start, and it should blink a couple times and fast if it joins the network, and this one is 7.63. So I can go back to my things and try to find my slider. Oops, I keep doing that. 63, I think it was. And sure enough, I found my slider. I save it, done. And you can see my other LED went offline because I unplugged it. Is there anyone that wants to play along that didn't get one? I have one more I can. And so then my slider has basically, I published a trigger at a threshold of 700 was in my blocks. And so now if I change my slider, it goes up, and then basically this is a way to get something like, if you had the distance sensor, I also have an example that sets a threshold so that if you're parking your car or there's trash or some sort of level and it goes above a certain level, that it should trigger at a certain amount. Unless I didn't write it right. So it's weird. And then just like I say, even though I can see the results in my laptop, if I were to disconnect this from power, I just need to prove this at least once, that it doesn't actually use my laptop to run. So now it's powered off this little power brick, and I should be able to still see the results. Sure enough. So now I have my semi-wireless, boy, there's a lot of wires here. So one of my other ideas, if any of you have connections to manufacturing that can do kits like this that could then have plastics associated with it, so you're kind of an in-betweener. It's not it would be a commercial product, but a commercial product where you can actually modify the software inside. Like, leave the exposed micro USB port if it's an indoor device and let people upgrade the hardware over time. That would be, I think, really cool to have or use the same electronics as a lot of these developer boards, but put it in a commercial product so that it's open source, open hardware design, and commercially available, and still looks pretty in your house, doesn't have all this. Yeah, question?
Just wondering if it passed, if it's
Well, yeah, so I wanted to show you, I bought some of these long USB cables, so you just buy a little powered USB brick would be one way to do it. For my garage, I don't care. Indoors, I'll get the Bluetooth low energy stuff that can run on batteries. And then there's also, so I've got, like this is a Thingy 52 that has a small LiPo battery to play with. This is kind of cool. And then Scilabs has this little sensor board. This, they claim, this has Zigbee. No, Bluetooth. This is Bluetooth. It's called the Thunderboard. And it runs on a coin cell battery and it has a whole bunch of sensors already on it. So
is this a big that lasts like a year or something?
yeah, yeah. So for the battery operated devices, more like this, I would, the problem with these boards is they're expensive. It's like $40, $50. So it's not, it's fun to build, but it wouldn't be the best option. So I think the best option would be for open hardware designers to make designs that are simpler and lower cost. And there are some companies that are building them, but also include the plastics so that they can look pretty in your house, the door sensors and stuff. An ocean? Yeah, yeah, that's another low power option. Basically, I'm looking for things that people can program if they want to, or learn to program with developer boards, but then share the option of turning it into a product in the country, in the location you are, and having schools and people do their own thing. Okay, let's see. Just want to make sure. So let's go over to, let me stop this and maybe do, yeah, thanks. So who wants to do a specific example? Like I could walk through or another example.
What use case
Yeah, or you have the hardware right there. Do you have the hardware that you can play with right now? Because you can play with this one. Or maybe The other thing I wanted to do was, while you're playing with that, one more thing, was to bring up this new gateway and just show you how that works. So let's go ahead and do that. What happens is there is, again, if you go to GitHub, so there's a guide. No, that's the wrong one. Back under my account, I have the 0.6 guide, things gateway guide that I need to update really quickly now that we're going to 0.7. But if you look at the MD version, this basically talks about what I'm about to go through with you live. Basically, what you do is you go to the Mozilla IoT Gateway is what it always broadcasts. So let me just scroll down. You look for Mozilla IoT Gateway. You fetch that. And it should just automatically, like you're in a Wi-Fi hotspot zone, pop up this captive portal showing the networks that it sees. And instead of going on to linuxconf.au, which is an IP address that I can't look up, I'm hoping it will find my things. What was it? Yeah, that was what I was looking for, right there. So I want that, and I have the same password as the linuxconf. So that's the other thing, is with your microblocks, if you want to connect to the new gateway once I get it put up, you can connect to Mozilla-things-2G and the same password as the linuxconf password. And then what happens is the gateway now is connected to this little Wi-Fi router board, and it's getting an IP address. And I would have to also, to show you that IP address, I would also connect to this same router. And I can show you. So we should be able to see. Oh, that's funny, I don't see it. So what normally happens to bring up a new router is you look for gateway.local and cross your fingers. You have to be on the right network, which I am. No, you can all join the same network. If I say ping gateway.local, I think I failed the redirect test. I must have fat-fingered the password, which sometimes happens. I might have to try that again. Refresh. Okay, let me see. So I'm just going to power cycle again. What happens basically is if it doesn't get on the network, or if you move it to a different network, it goes back into the popping up of being an access point, and you connect to it and redirect it. But if I typoed the access point password, or if I didn't actually get it right. I wonder if it didn't change. The other thing to do, which is going to be convenient, would be, see if I can, oops. Okay, that means it means that it's not, let's see. Okay. There's- Okay, wait, no, that's the Guardian one. Oh, I know why. Plugged it into the wrong one. There it is, gateway. So the default is going to be gateway, and this way I can get at it like this. Okay, so whatever, when I typed the Wi-Fi password, I failed, obviously, because that's the next thing that it's trying to do is do this again. So I'm going to just check my password. I think that's correct. And the other thing to do is, did I or did I not put the SSH key in there? So this is 126. Check really quick if it's got wireless here. I can take cash, PayPal, promissory notes. Yeah, Kathy_Jory@pobox.com is the email I use for that. I could type that somewhere. Just, yeah. I haven't. So Kathy_Jory@pobox.com. That would be if you wanted to do the PayPal. Just leave that there for a second. Basically, first name underscore last name, which you can look up, and then pobox.com. It's just a mail forwarder. So I should get it then. All right, where are we here? 26. So just want to get you through this setup here. I keep filling the Wi-Fi. Let's skip the Wi-Fi so that we can go on to the next step. because the domain part is the fun one. Here we are. This is what I wanted to get to. So does anyone have a subdomain we should try? Not one that you want for yourself, because once I type in my email, it's going to be taken. LCA 2019. Yeah, because it won't be very useful after this year, right? Oops. Okay. And the keep you posted is basically a quarterly email that says we're updating the gateway, because it happens automatically, but then you know it's going to happen. So don't be too worried about it, or you can just uncheck that box. And then what happens is it's processing and installs a certificate, and normally it says success, and it goes, yeah, there we go, success. Please wait while we redirect you. So it does all of the, if you actually look in the log, it's got all those hashes coming and going. And the next thing, there's one more step, which is basically giving it your first username. And this is, again, this is local. You're not signing up with the cloud. This is just how you will log in. So the email address doesn't even have to be real. It just has to look like an email address. So actually, I'm going to do a demo user so that you can all log in. So we're going to call it demo at example.com. And then we're going to use the same Wi-Fi password. You all know what that is. The Linux conf AU password. So now you can actually all go in, because with this wireless access point, you can use, I don't know why the Wi-Fi is not working. I'm going to have to try one of these pointing at that. That's what I'll do next. Oh, the next thing it asks is, do you want to allow notifications? Here's another one where normally you would say no, but you just say yes, because the only one who can send notifications is yourself through the rules engine. So if you don't put a notification on the right side of the rules engine, you will never get a notification. So you're the one that sets that. And if you make a mistake, go in there and change your permissions later. So basically, this is how it comes set up. And then usually what I do is go into developer mode and enable SSH so that I can go over here and change the password right away. I just want to let you know that the default password known the world over is Raspberry. Username Pi, password Raspberry. So the first thing you have to do is change it from Raspberry to something else. Yep, and I can't. Yeah. Okay. Too simple. Okay, we succeeded. And they do move things? Yeah. Oh, we're running out of time. Okay, gosh. Okay, we have run out of time. So I was just going to show you the log run app.log. What is it? 20 something. Oh, wait. Just for grins, you know, when you're booting up your own gateway, you can be able to look at the logs and see what's going on and so on and so forth. This stuff is mostly written up in our wiki. And add new users, add on. So you can experiment with the gateway, and then we should be able to fetch something and see if we can get it to talk to the same network. I just want to see if this works. Sure. So I'm not that difficult to find because Kathy Jory seems to be unique in the world of LinkedIn and Facebook and everything like that. So, but watch out for Katie Jory, my, as of last year, new daughter-in-law. So I'm Kathy, she's Katie. Yeah, so now, I think what happened was the password that I thought I changed on the router didn't actually change. So that would be the reason why we couldn't get through the Wi-Fi setup. And sure enough, I changed back to my old password and it connected. So 2.230 would be the way that we can connect something. So if we had more time, you all could connect up to this you could all connect up. Oh, in fact, somebody got their temperature sensor up here. All right. Woo! Okay. So the temperature property is new, and I had, when I had that problem, I stopped it and I started it again, and then it worked.
Have you tried turning it off?
And that only happened with the temperature sensor. I don't know if the temperature sensor needs some like kicking and then stopping and then kicking started again, but that actually happened to me as well. That it, yeah, if you restart it.
Thank you very much.
Thank you guys.